last class, I have explained that whenever any element or the atom lose the electron, it always requires some energy. So in this way, like 281, this is the electronic configuration of sodium. To complete its octets, when the one electron is lost by it, always it required some energy. But in contrast to that, suppose I have taken the example of chlorine, where the atomic number is 17 and the electronic configuration is 287. To complete its octet, that means 8 electrons in its outermost shell, it will gain some electron. So whenever any element gain an electron, there is always release of some energy. So what is the basic concept? When the electron is donated, there is always requirement of some energy. When any element accepts electron to complete its octet, there is always release of some energy. Now, I want to explain the relationship between the atomic radius and the ionization potential. I have told you whenever in a group you move up to down, there is always one shell increase. Okay? The shell is increased by 1. So, when you move up to down, the shell is increased by 1, or indirectly you can say that the atomic radius is increasing. So, there is a formula by which atomic radius. Force, this F, that means the force of attraction by which the nucleus has bounded the electron towards itself. So, in this force of attraction and the atomic radius, there is inverse relation. Inverse relation means when the atomic radius is increasing, the force of attraction by which the electrons are bounded by the nucleus is decreasing. In other words, when the atomic radius is decreasing, the force of attraction by which the electrons are bounded by the nucleus is increasing. So in other words, you can say if you compare in two conditions, that the atomic radius is more. That means the force of attraction is less. Force of attraction is less, that means electrons are loosely bonded. And here the atomic radius is less. That means the force of attraction is more. Now come to the point. When in this condition the atomic radius is more and the force of attraction is less, that means the electrons are loosely bounded. That means the electron has a natural tendency to remove itself and it doesn't require the more amount of energy. Automatically the electron can be removed because it is loosely bounded. Loosely bounded, that means the requirement of energy by which the electron can be loosed is less. While in this condition where the atomic radius is less, they are tightly bounded. Tightly bounded, that means for the removing any electron from its outermost shell, it required more amount of energy. So when it required the more amount of energy, that means the ionization potential is more. Because what is the ionization potential? The ionization potential is the amount of energy required to remove the electron. So to sum up all these, there is the inverse relation between the force of attraction by which the electrons are bounded with the nucleus and the atomic radius. So where the atomic radius is more, that means the force of attraction is less. Force of attraction is less, that means electrons are loosely bonded. Itself it can remove, that means the amount of energy that is required to remove the electron is less. The amount of energy required to remove the electron, that means, in other words, you can say the ionization potential is less. So where the atomic radius is more and electron itself, it can be removed loosely bounded, so the ionization potential is less. But where the atomic radius is less, that means they are tightly bounded. Tightly bounded, that means for so that the electron can be removed, it required the more amount of energy. More amount of energy, that means the ionization potential will be more.